right, let's look at an application using velocity. And so let's say that we have a lifeguard and we need to rescue a swimmer who's in distress on the North Shore. The swimmer is perched on a rock. So here's the swimmer perched on a rock. They're holding on. Okay. They are directly across the beach. They're directly north of the beach, okay? And then the speed of the lifeguard's jet ski is without the water, so just its own velocity is 14 miles per hour. And then we have a current that's flowing east at 6 miles per hour. Okay, and we want to know at what direction, what bearing should the jet ski head in order to get to the swimmer. Okay, so let's let C just stand for the current vector. Okay, and then I'm going to call the boat that's going with the current, and then there's a boat just without, just on its own with no current. So this would be boat without current. Okay, without the current, and then this one is the boat that's been affected by the current. Okay, and we're being asked to find what should the bearing be of the jet ski. So they should head away from the current, right? Because the current's going to push them back towards the swimmer. So this is the angle that we want. We want to go north and then some, okay, and then some bearing headed towards the west. Okay, so that's what we are trying to find, right? North, west, south, and east. So we're trying to find this angle right in there. That's what we want. Okay, so we know that the current is going directly towards the east, and that's at a velocity of 6 miles per hour. So what we can do is let the magnitude of the velocity be representing the speed. Okay, so the velocity and the magnitude, those are going to be the same thing for our problem. So that is the magnitude of the current. That's 6. Okay, now let's see, this is the boat just on its own, and it has a magnitude of 14. And what we want to know is the angle. Well, because of the way this problem is set up, where the rock is directly north and the current is coming directly from west to east, there's a 90-degree angle there. So we can just set up a nice simple trig function. Because the sine of an angle is the opposite over the hypotenuse, we would get the sine of the angle that we're trying to find, theta, is equal to the opposite, which is 6, over the hypotenuse, which is 14. And then we'll just use arc sine. And so we get, let's get this in a little bit, we get our angle is approximately 25.4 degrees, and then we'll just write that as a complete sentence. So the lifeguard should head in the direction of north 25.4 degrees west, and then that current will blow him or her right towards the swimmer. Let's try another one. So we have a plane heading due east at 400 miles per hour. So that's going to be our magnitude, okay? And then we have a crosswind coming 50 miles an hour, blowing in the direction of north 30 degrees east. So what we need to do is find the true velocity, so that's the plane as the wind is affecting it, its speed, and its direction. Okay, so we'll first draw a diagram. So just like to draw this out: north, west, south, and east. Or allow. Okay, so now we have a plane heading due east at 400 miles per hour. So here's my plane. And the magnitude there is 400. Okay, good. And now we have a wind, and that is traveling at 50 miles per hour, and that little angle in there is 30 degrees north, 30 degrees east. Okay, so we can, adding these together, we would start at our 400, but then the wind is affecting it, and so the resultant vector, that right there is going to be the true vector. So I'm gonna just define some variables here. Let's let W be the crosswind, and then let's let P be the plane, and that without the wind. Okay, and then the plane as it's being affected by the wind, that I'm going to just call PW. That's the plane with the wind. Okay, so I need to find the speed and the direction. So what I need is the speed, that's going to be the velocity of the plane with the wind, and then I also need its direction. Okay, so what we know so far, the plane is traveling directly east. So that means that it has an x component of 400, and no, it's not traveling at all north or south. So that vector is pretty straightforward. Now, the wind vector is a little bit more complicated. I'm going to go ahead and just draw a little diagram, just kind of zoom in on that wind. Okay, so here's our wind. We knew that this angle right in here was 30, and so by complementary angles, this is 60. The wind has a velocity of 50. Okay, so now, the x component, that is 50 times cosine of 60 degrees. And because cosine of 60 is 1/2, then that gives us that x is 25. So for our wind, we have an x of 25. And then the vertical component is 50 times sine of 60, and that is about 43.3. Okay, but what we need to know, what we're being asked to find is the resultant. When you're adding those two vectors together, you would get the plane as it's been affected by the wind. And we need the direction, and we also need its speed. Oh, that was the other thing. Okay, don't forget that. And that is its magnitude. Okay, so first of all, let's figure out what that vector is. Okay, so the plane as it's been affected by wind, that would be the plane and the wind. And so we just add those two vectors together. So 400, 0, that's the plane, and then 25, 43.3, that's the wind. Adding those up gives us our new resultant vector, 43.3. Okay, now we need to find its speed, and that is the magnitude. So we would have 425 squared plus 43.3 squared, square root of the sum. Okay, so we get approximately 425.2, and we're in miles per hour for this problem. Okay, so my next thing is I need to find the direction. Okay, and the angle, we can come back to our diagram here. Our angle, here I'll make another little, okay, so this is plane with the wind. We need this angle. Okay, back in here was other one. We have a 90-degree angle, or we can make one if you just take and look at the horizontal and vertical components of our vector. Horizontal, 425. Vertical, 43.3. Okay, and so the angle would be the tangent of our angle would be opposite over adjacent. So 43.3 over 425. Pull out your calculator and let's figure out arctan. Okay, so arctan of 43.3 over 425. That gives us an angle of approximately about 5.8. Okay, but usually we give direction in terms of bearings. Okay, so if this is north, we're going to be turning in the direction of west. This we found is that little 5.8. So just subtract that from 90 and we'll travel at a bearing of north and 84.2 degrees west. So the plane's true velocity is 42.5 or 425.2 miles per hour, and it's flying in the direction of north 84.2 degrees west.